It's trigonometric Fourier series representation for this waveform, half wave rectified sine waveform with x of t over this side and t over this side, and the intervals are 0 to pi, 2 pi. Now this is one complete time period for this one, saying that this is t, and we have that pi by 2 over here, 3 pi by 2 over here, and so on. Now the trigonometric Fourier series representation for this one. It's a sine wave, and usually x of t, the general expression for x of t for a sine wave will be a sine omega naught t, a sine omega naught t, and omega naught we have another value from the waveform. General expression omega naught is 2 pi f naught frequency still, which is 2 pi by t, the time period t, and from the waveform it's 2 pi by t is pi over here, 0 to pi, it's a pi, and this gets cancelled, and finally we have the value for omega naught equal to 2. And with this one we're gonna have that x of t expression as x of t, hereafter x of t will be a sine 2t, and now this has to be, like, we have to make use of this expression to evaluate the Fourier transform, Fourier series, trigonometric Fourier series representation for this sine half wave rectified sine wave, and omega naught is 2, which we will be making use of through the entire derivation, evaluating the coefficients and all. And general expression for trigonometric Fourier series representation is x of t is given as a naught plus the summation n equal to 1 to infinity a n cos n omega naught t plus bn sine n omega naught t, inside the bracket to say that an, bn, we have to expand that as part of summation. Here we need to evaluate a naught, an, bn, and a1, a2, a3, a4 further from that general expression for an and bn. And guys, remember, in between we come across some trigonometric identities, and so the name itself says trigonometric Fourier series. Trigonometric identities comes in between, and evaluating for a naught, then the general expression is 1 by t integral t naught to t naught plus t x of t dt, and plugging in the values of t and the limits and x of t, what do we have? T is 1 by pi integral, if you watch carefully the picture, this integration will be from 0 to pi by 2 for one complete cycle, and x of t we have a sine 2t dt, and integrating this one a by pi and minus cos 2 t with the limit 0 to pi by 2, plugging in the lower and upper limits a by 2 as it is, minus cos 2 into pi by 2 comes in the place of t, so pi by 2 minus lower limit minus, we already have this minus, plus, and cos 0, that will be 1. And what do we have, guys? This gets cancelled here, this 2 gets cancelled, and inside this one we have cos odd pi, which gives us here, this is minus 1, and what do we have? Minus 1 and minus 1, and one more correction over here. Integration sine 2t is cos 2t minus cos 2t by 2, isn't it? I forgot that one. So we have that 2 over here. This makes minus plus 1, and we have, inside the bracket we have this 2. So this gets cancelled, and here, and finally we have a by pi, in the sense expression for, coefficient a naught will be a by pi in this case. I forgot over here sine 2t cos 2t by 2, we have that one, that gets cancelled, and finally we have a naught equal to a by pi. And yeah, we need to evaluate general expression for an, and that, making use of that one, we evaluate a2, a3, a4, a5, and why not an? Yes, we have a problem with the a1 in the an. Expression for an is given as general expression 1 by t integral t naught to t naught plus t, x of t is multiplied with cos n omega naught t, and then the integration comes in between. So plugging in t, limits, and x of t for the further evaluation, t is pi, integration is from 0 to pi by 2, x of t is a sine 2t cos n, omega naught is 2 again, remember, throughout the entire process. And here we go dt, and take a pause. Here we come across a trigonometric identity including guys, once again I am really sorry, it's an will be 2 by t. I'm sorry, I'm taking back, I'm correcting over here. 2 by t, it's not 1 by t, it's 2 by t, and so we have that 2 also here also. Alright, I'm repeating, it's 2 by t, it's 2 by t, x of t cos n omega naught t, and this one. Alright, so including this 2, we have a trigonometric identity over here. It's 2 sine a cos b, which is sine a plus b plus sine a minus b, including this 2. So a upon pi, that's as it is, integral 0 to pi by 2 integration 2 sine a cos b, 2 sine a cos b, sine a plus b plus sine a minus b, sine a plus b in the sense 2t plus 2nt, taking out 2 as common, 1 plus n inside and t also as common from both the terms, plus sine a minus b in the sense 2t minus 2nt, 2 as common, 1 minus n inside the bracket and t also as common. Here we go for that integration dt, and further a upon pi, integrating this one, integral sine theta d theta, it will be minus cos, isn't it? Minus cos, what do we have? 2 into 1 plus n t upon 2 into 1 plus n for this one. This is for this. And the second term, minus cos 2 times 1 minus n into t by 2 times 1 minus n with the limits being 0 to pi by 2. Alright, and we have to plug in the lower and upper limits. A by pi, and guys, first term with upper and lower limits, let's see, and one more thing, one more small simplification over here. This 2 and this 2, 1 by 2 can be taken out as common, so over here. Alright, so for the simplification to be easier, this one. Alright, whatever 2 has appeared over here, I pulled it out, so we have that 2 over here. And for the this term with the lower and upper limits, let's check if what is going to happen. Upper limit, minus cos 2 times 1 plus n into pi by 2 by 1 plus n, minus lower limit, isn't it? Minus lower limit, we already have a negative, so it will be positive. Cos 0, that will be 1 by 1 plus n for the lower limit. For this term, minus cos 2 times 1 minus n and pi by 2 in the place of t, so pi by 2 by 1 minus n for the upper limit, minus lower limit, minus, we already have this minus, that will be plus 1 by 1 minus n, and this will be the general expression for calculating an, different values of an, in the sense a1, a2, a3, but we don't make use of this expression to calculate a1. The problem over here is, make a note, the problem we don't calculate a1 making use of this. Why? Because come over here, plugging in the values of n equal to 1, 1 plus 1, 2, that isn't a problem. 1 plus 1, that isn't a problem, but the problem is over here. 1 minus 1, this will be 0, making this term to be infinite. 1 minus 1, that will be 0, this ratio will be infinite, making the coefficient a1 to be infinite, and the entire series will be tending to infinite. No, we don't have infinity. We have another approach to calculate a1. For the time being, n equal to 2, which gives us a2. Let's check. It's a by 2 pi. Alright, minus, and one more thing, even more a simplification over here. Getting back, this 2 and this 2 gets cancelled. Alright, even this 2 and even this 2 gets cancelled. Make a note of this one. Here, I'm sorry, this has to be cancelled. This. So we don't have this 2 anymore over here, and even this 2 gets cancelled. This, and over here also, this 2 and this 2. We speak, it will be only cos n even pi or an odd pi, making it minus 1 or plus 1 according to the pi. Alright. So n equal to 2. N equal to 2 in the sense minus, this will be cos 1 plus n, in the sense 1 plus 2, 3 pi by 3 plus 1 by 3 minus cos 1 minus, we are going for n equal to 2, isn't it? 1 minus 2, that will be minus pi here, by 1 minus 2, that will be minus 1, and plus 1 by 1 minus 2, that will be minus 1. Here, this negative, that becomes positive, and we have a negative over here. Let's check if what simplification can be obtained over here. So guys, here we have a negative, and this is a odd pi, which makes this cos 3 pi gives minus 1. If you want to check it with your calculator, like put your calculator in radians mode and then check if what is cos 3 pi. That will be minus 1. In the sense, we have minus 1 over here, this minus 1 and this minus, that will be plus. So we have 1 by 3 over here, plus 1 by 3 from this one, and even over here plus. It's a cos pi, minus pi, odd pi, that will be minus 1, and even this is minus 1. So what do we have? 2 times 1 by 3 minus 2, and simplifying this one, what do we have? It's a 3, 2 minus 6, it will be I forgot to mention, this is inside the bracket. Okay, this is inside the bracket. We have that a by 2 pi, which is equal to a by 2 pi, and it's 3, 2 minus 6, which is a by 2 pi. We don't touch it. This will be minus 4 by 3, 2 times, and it's a minus 2a by 3 pi. For what value is this? A2. A2 is found out to be minus 2a by 3 pi. In the same way, we compute different values of the coefficients with n equal to 3, 4, 5, 6. Let's see what happens with the different values of n over here. X of t is this. Okay. N equal to 3. In the sense, we go for A3. A by 2 pi, we don't touch it. Here, minus cos 3 plus 1 plus 3, it's a 4 pi by 4 plus 1 by 4 minus cos 1 minus 3, it's a minus 2 pi even pi by minus 2, 1 minus 3, and plus 1 by 1 minus n minus 2. Let's check if what happens. A by 2 pi, it's as it is. And guys, it's a, here, watch carefully, it's a even pi, cos even pi, that will be 1. In the sense, we will have minus 1 by 4 over here, plus 1 by 4 from the previous one, and this negative, this will be positive, that's okay, plus 2, this is even pi, alright, this is even pi, so that will be 1, cos even pi, that will be 1, and we have that negative over here, which gives minus 1 by 2, minus 1 by 4 plus 1 by 4, plus 1 by 2 minus 1 by 2 gets cancelled, and this is 0, and this is 0, entire thing. A3 is found out to be 0. Alright, in the same way, we're gonna calculate 4 different values of the coefficients with the n different values of n. Now, A4, let's see what happens with the A4 in the sense, n equal to 4. N equal to 4 gives us A4, that which is equal to a by 2 pi and minus cos 4, right? 1 plus 4, 5 pi by 1 plus 4, 5 plus 1 by 5, and this will be minus of 1 minus 4, cos minus 3 pi by minus 3 plus 1 by minus 3. 1 minus 4, it will be minus 3. A by 2 pi, guys, this is odd pi, which gives minus 1 over here. This will be minus 1. This minus, that will be plus. So 1 by 4 plus, sorry, guys, it's a 4, so it will be 5. It will be 5 over here, n plus 1, right? N plus 1 and 3, yeah. Now this one will be 1 by 5 plus 1 by 5 plus 1 by 5. This is negative, this will make positive, but still, let's check. This is an odd pi, that gives us minus 1 over here, so minus 1 by 3, and from here it's a minus 1 by 3, which is a by 2 pi, twice of 1 by 5 minus twice of 1 by 3, which gives a by 2 pi, no change in that one. 5 3s are 15, 3 2s are 6, minus 5 2s are 10, which gives a by 2 pi, and here we have minus 4 by 15, still, which is 2 minus 2a by 15 pi. The value for A4, A4 is minus 2a by 15 pi. Alright, so it's a A4. A5 this time, A5 this is the way we calculate for different value, different coefficients which we need to construct the trigonometric Fourier series extended. That summation A1, A2, A3, A4. A1 is also supposed to be 0, that has to be proved. Now that's A4. N equal to 5 gives us A5, which is equal to A by 2 pi and minus cos 1 plus n, 1 plus 5, 6 pi by 1 plus 5, 6 plus 1 by 6 minus cos. What do we have? 1 minus 5, it's a minus 4 pi by minus 4 plus 1 by 1 minus n, 1 minus 5 minus 4. Alright, so it's a by 2 pi. Now this one we have negative, that's okay, but it's a cos even pi, that will be 1 plus 1, so minus 1 by 6 plus 1 by 6. Okay, like this makes positive, but still what happens? Cos even pi, that will be plus 1 here, so plus 1 by 4, and we have a negative minus 1 by 4 cancelling each other. It's in the sense a by 2 pi, that's okay. Inside the bracket minus 1 by 6 plus 1 by 6, this one it will be 0. So A5 that is also a 0. From this very pattern we can predict that A1 also will be 0, but still we have to have a proof for that one, and that is done with another approach, but not this one, from not this A and all, right? So n equal to 6 this time. A6 that will be A by 2 pi minus cos 7 pi, alright, minus cos 7 pi by 1 plus 6, it's a 7 plus 1 by 7 minus cos 1 minus 6 in the sense minus 5 pi by 1 minus 6 minus 5 plus 1 by minus 5. What changes over here? This is a odd pi resulting into minus 1. So minus 1 into minus 1, like minus into minus, it's a plus. So a by 2 pi 1 by 7 plus 1 by 7. Yeah, once again this is a plus, but still it's an odd pi resulting minus 1 by 5, and here we have negative minus 1 by 5. Simplifying this one, it's a by 2 pi twice of 1 by 7 minus twice of 1 by 5, which is equal to a by 2 pi and 7 5 35, 10 minus 14. Alright, 10 minus 14, and what do we have? A by 2 pi into minus 4 by 15, 35. I'm sorry, 35 twice, so minus 2a by 35 pi. What value is that? For A6 is found out to be minus 2a by, it's a 7 5s, right? 7 5s, okay. So 35 pi. Alright, and in the same way, A7 also will be 0. A7 also will be 0. Alright, A7 also will be 0, even that has to be shown. N equal to 7, which gives us A7, that is a by 2 pi minus cos 1 plus 7, 8 pi by 8 plus 1 by 8 minus cos 1 minus 7, 6 pi minus 6 pi. Alright, by minus 6 plus 1 by minus 6, and here this is a positive once again. And what else? A by 2 pi, what justification? It's a even pi, so we have 1 over here, and we have negative minus 1 by 8 plus 1 by 8, and what do we have? It's a even pi, so it will be 1 only. So plus 1 by 6, we have a negative minus 1 by 6 over here, and minus plus gets cancelled each other. A by 2 pi is multiplied with 0, resulting into a 0. What's that? For A7 is also found out to be 0. Alright, so this is the way we find out the different values of, and one more coefficient, and that will be enough, I guess. Alright, so one more. Okay, like it's enough, like AC up to A6. A7 will be minus 2a by 7 9 63. Minus 2a by 63 pi, check it, it's for your task. A8, okay. And what is the general expression for an? It's a 2 by t integral t naught to t naught plus t. X of t is multiplied with cos n omega naught t and dt, isn't it? And n equal to 1 in this expression itself. A1 will be 2 by pi, t is pi in our case, in the given waveform it's 0 to pi by 2, the limits for integration. X of t is a sine 2t cos n equal to 1, it's a 1, and omega naught is 2t dt, and another trigonometric identity has come in over here, including this 2, the sine a cos a, sine 2 sine a cos a, which is sine 2a, isn't it? And now a is 2t over here, please don't get confused over here. So that a by pi, that's okay. We have that integration 0 to pi by 2. Alright, it will be sine sine 2a, sine like a 2 times sine a cos a, it's a sine 2a. A is 2t over here, so we have 4t dt. 2a, a is 2t, so 4t we have here. And integrating this one, a by pi, integrating minus cos 4t by 4 between 0 to pi by 2. Alright, so a by pi, plugging in the upper limit, minus cos, what it is, cos 4 into pi by 2 minus plus, in a sense, actually what we have, minus lower limit, isn't it? Minus, we already have that negative, so this will be positive, plus cos 0, 1. And here itself, it's a 2 pi, it's a 2 pi. It's a even pi, this one, inside the bracket, it's a even pi, resulting in 1, so this will be minus 1, and plus 1, this will be a 0. In the sense, a by pi, no change in that one, inside the bracket it's a 0. So here in between we come across a1 to be 0. This is the proof we have to show. Alright, so this is for an part. Remember, a8 will be minus 2a by 7, 9, 63 pi. Remember, you can try to compute that one. Make use of your calculator. Now, that expression for Bn, which is to be plugged into the series. Bn, and general expression for Bn is, what do we have? Bn is given as 2 by t again, integral t naught to t naught plus t. X of t is multiplied, this time it's multiplied with sine n omega naught t dt, and the changes to be for this and this. 2 by pi, integration is from what? 0 to pi by 2. X of t is a sine 2t, a sine 2t, and sine n, okay, omega naught is 2t dt. Alright, so once again we come across an identity 2 sine a, sine b, that is cos a minus b minus cos a plus b, but still wait, hold on, n equal to 1, which gives us b1 from this one. A small change in over here, it's a 2a by pi, integration 0 to pi by 2 sine 2t sine n equal to 1, b1, n equal to 1, so this is 1, so 2t dt, that which is equal to 2a by pi, integration 0 to pi by 2, it's a sine square 2t dt. Another trigonometric identity comes over here, which is 1 minus cos 2 theta by 2, which is 2a by pi. Where did this 2 come from? From the expression, and pi in the place of, okay, done. Integral 0 to pi by 2 sine square theta is 1 minus cos 2 theta, in the sense 4t by 2, and here this 2 and this 2 gets cancelled, we don't have this 2 anymore, getting cancelled with the denominator 2, and we have that integration for this one dt. Alright, so this is for B1. We are trying to calculate for B1. All right. We are trying to calculate for B1, and B1 is found out to be B1. Further simplifying, a by pi. All right. And integrating directly, integral 1 dt, that will be t between 0 to pi by 2 minus integration for this one also, in the sense sine 4t by 4 for the for the limit 0 to pi by 2, and close this one for this one. This is for this for that, and yeah, we have that. All right. So I guess I'm going right. And B1, further, B1 will be a by pi. All right. For this one, for this pi by 2 minus 0 for the first term, minus sine 4 into pi by 2 by 4 minus lower limit plus sine 0 negative for this one. All right. Sine 0, it's a 0. We don't no confusion over here. Sine 0, it's a 0. Even this one 2 times sine n pi, even that will be 0. Sine n pi, any values of pi over here, it will be 0. So 0, 0, this term will be 0. So B1 is a by pi into pi by 2 gets cancelled, and a by 2 is the value for B1. B1 is found out to be a by 2. Alright, it's a by 2 for B1. Now Bn is B2, B3, B4, B5, all are zeros, but that has to be proved. Bn, it's a 2 by pi, integral 0 to pi by 2. X of t is a sine 2t multiplied with sine 2nt and integrated with respect to t. Here this one, sine twice of sine a, sine b, resulting in including this 2, alright, includes in the identity. A by pi, integral 0 to pi by 2 cos a minus b, 2t minus 2nt, 2 into 1 minus n into t, minus cos 2 into 1 plus n into t, and then we have that dt. And a by pi, and integrating this one, what do we have? Integrating this, we have cos, integral cos, it's a sine 2 into 1 minus n in n t by 2 into 1 minus n minus sine 2 into 1 plus n into t by 2 into 1 plus n with the limit 0 to pi by 2. Alright, so 2 comes out. Anyways, this result will be 0 for any values of n equal to for different values of 2, 3, 4, 5. Check it. Like upper limit, sine 0, lower limit is anyway, it's a 0. Plugging in the upper limit, for in both the terms, the upper limit is pi by 2, isn't it? Pi by 2, and here this 2 gets cancelled, this 2 gets cancelled. Alright, so it's a sine n pi. Sine, it will be n pi. Sine n pi is anyways 0 for what values of n also? 1 minus 2. It's a sine minus pi, that will be 0. Sine any value, like any values of n, plug in over here, check in your calculator. The numerator will be 0, not this one. We have already calculated for n equal to 1, that is this value. For any values of it's a sine n pi, that's a 0, in the sense bn, whatever value, b2, b3, b4, b5, everything will be 0. All the coefficients will be 0. Only those coefficients will be existing in the trigonometric Fourier series representation as far as this waveform is concerned, and those are enough. Alright, so if you calculate A8, that will be minus 2a by 63 pi. Check, it is your work. Now x of t is what is that? A naught plus summation n equal to 1 to infinity an cos n omega naught t plus bn sine n omega naught t. Alright, in the sense we have to expand for a1 cos omega naught t, a2 cos 2 omega naught t, a3 cos 3 omega naught t, etc., and then the series completes. Alright, and like a naught plus a1 cos omega naught t plus a2 cos 2 omega naught t plus a3 cos 3 omega naught t plus etc. It tends to infinity for this, and b1 sine omega naught t plus b2 sine 2 omega naught t etc. It goes on to infinity. And remember, a1, a3, a5 are zeros. a1, a3, a5s are zeros. We don't have these coefficients. a1, a3, these are like we only have that even coefficients, and also b1 from the second series. All right, so from the odd series, b1 only, and the complete Fourier series representation. A0 is, what's A0? It's a by pi. A by pi plus, no, we have minus. Why? Because a2 is minus 2a by 3 pi cos n is 2 omega naught t minus a6. We have a4 minus 2a by 15 pi cos 4 omega naught t minus 2a by 35 pi in the place for a6 isn't it, cos 6 omega naught t minus 2a by 63 pi cos 8 omega naught t minus, it goes to infinity, plus b1 what was that? b1, where did it, a by 2, b1 is a by 2 sine omega naught t, by because n is 1 in that case. And now like different authors, they change the representation in some other way, and one standard form is x of t is a by pi plus this comes this is taken forward, a by 2 sine omega naught t minus 2a by 3 pi cos omega naught t minus 2a by 15 pi cos 4 omega naught t, isn't it? A naught, sorry, this is 15 pi, 15 cos 3a by, it will be 2, a2, isn't it? A naught, a2, yeah, 15 pi cos 4 omega naught t minus 2a by 35 pi cos 6 omega naught t minus 2a by 63 pi cos 8 omega naught t minus tends to infinity. All right, this is not this one. This is the complete series. Furthermore, a little bit the simplification over here is something can be taken out as common from all these terms from here to infinity. Some x of t a by pi, guys, what if plus 2a by pi is taken out as common from all the terms? So we have 2a by pi, isn't it? So what do we have? Pi by 4 over here. Why? Because a by 2 into pi by 4 like that. Okay, so pi by 4 can be taken out as common from this one if we take out 2a by pi as common. So it will be sine omega naught t. So multiply this 2a by pi into pi by 4. What do we have here? It's a 2a by 2. What do we have? Yes, we get back to this a by 2, taking out 2a by pi as common. I got confused. Alright, so and 2a by pi has come out. So what do we have? Minus cos 2 omega naught t by 3. This has come out. So minus cos 4 omega naught t by 15 pi has come out. So minus to infinity. This is the final trigonometric Fourier series representation for the half wave rectified sine wave. That's it.